everyone. Welcome to the panel on zero knowledge proofs, where we are about to explain everything you need to know without actually telling you anything. All right, I'm gonna present a list of awesome speakers, starting with Sir Ingo Rube, from the founder of KILT protocol, an identity protocol that provides secure and practical infrastructure for enterprises, governments, and consumers. Hello, Ingo. All right, next on, Marco Marinelli from Horizen Labs. Marco contributes to ZK Verify, a modular zero-knowledge proof verification chain aimed at democratizing the adoption of ZK proofs. He's also the one with the longest hair on the panel. All right, next one is Martin Ivanov from Blocksense. Martin is a software performance and metaprogramming enthusiast. His interest in cryptography brought him in the Web3 space only a year ago, and in that short time, he gained experience in developing trustless oracles, leveraging the highly scalable, recursive, succinct proofs. I mean, I've been in the space for 7 years, and I don't understand a word of this. Big brain. All right, the panel is going to be moderated by Rosen Santev, sorry. Rosen is the co-founder and CEO of Assetify, a pioneering platform in digital asset-backed lending. Welcome to the stage, everyone, and I leave the word to you.
Okay, you hear me well? I think yes. Guys, I want to tell you something. First, I'm so happy to be here, as you can understand. I'm happy that Bulgaria is hosting such a great conference, ETHSofia, pretty nice. And yes, I have to share one story with you. Actually, a few days ago, I was talking with my mother, my parents actually, and I was telling them that I'm gonna be a part of this conference. We're gonna be talking about Web3, privacy, identity, zero knowledge, smart contracts, all this stuff. She was looking at me like, I don't know what you're talking about, but I'm proud of you. And the case is that these people here, they're experts in zero knowledge, and I can tell you that even an experienced blockchain developer sometimes feel like my mother. He knows about zero knowledge but can't understand anything. And I really hope that these guys here are gonna help us to understand this technology better and are gonna give us advice about what is gonna happen in the next years with this technology. Okay guys, so to warm up our audience a bit, let's talk first about what has changed in zero knowledge in the last 2 or 3 years. Marco, maybe you can start here.
Okay, amazing. So thank you for the question. And I think that zero knowledge itself has changed a lot in the past years. And the reason for that is, like, if you think about zero knowledge at its inception and at the end of the 80s, it was theorized as a concept, but it didn't found an application immediately because of different constraints, like all the computational power required to implement the system and also for verification. And in the last year, with the advent of blockchain, ZK and blockchain came together kind of as a complementary technology. And I think that in the last years, we have seen like a Cambrian explosion in the field of zero knowledge, seeing more proof schemes developed, the academic being interested in researching new technologies and improving on the existing ones. And yeah, I think that a lot of real-world implementation are coming out straight off that research, and it's very cool to see something being theorized and implemented just a few months later.
Okay, so as we can see, it is now, the technology is improved, it is more secure, more like finished, let's say. But is it easier for the people to use it, like for people to understand what is it about, how it works, and is it easier for them to apply it in their products to resolve problems that this technology can resolve?
So I would say in terms of is the technology ready to be used, the answer is yes and no. The point is that all the building blocks of the technology are in front of us. The hard part is to choose the best ones and put them together to have the most efficient system we can dream of, basically.
Martin, maybe you can help here as well. Like, you started working with this type of technologies 1 year ago, and how do you feel it? Was it easy for you to find information, yes, your knowledge about the topic, was it easy for you to start working on it and be good part of blockchain development team?
So I've been thrilled with the resources about blockchain. They're very good, but the zero knowledge information is not really out there. It's very hard to find. It's not hard to use per se. The underlying technology is getting harder and harder to grasp at a deep level, but if you imagine it as a black box, it's not really that hard to understand how it applies and how it can be applied.
Interesting. Okay, I hope in the next years we will be able to see improvement in this specific topic, because it is very important. If there are no people that understand and can work with it, it will be a problem to adapt it as a technology and use it, because as I believe, and maybe everybody here believes, it is useful. It can be useful. What about?
If the metric is easy to use, it's definitely getting easier to use. If you're metering how easy it is to understand, it's harder to understand, not easier as the time passes.
So to conclude, it is easier to use it, but harder to understand it.
Yes.
And do you think this can be a problem, like using something that you don't understand?
Well, there will always be people who understand it at some deeper level, and you can put your trust in them. I'm not that kind of person. I like to dig deeper and understand more and not trust anyone and take their word for it. So it depends on the audience. For me, it's not a good thing that it's hard to understand.
I believe that's why you've made so much just for 1 year, because you're interested in understanding the topic. But yeah, I believe most people in blockchain, they all want to understand what they're using, because the decentralization is what is important for us, our privacy, and that's about not being controlled from somebody else. What do you think, guys, about this?
When I think of zero knowledge, I think it is mostly a topic where probably a lot of PhD theses of mathematicians have to be written still. It is a highly common, so I'm a computer scientist and I'm not a mathematician. My wife is a mathematician, and she somehow tends to understand what it actually is, how it actually works. So we all know what it is. It is actually pretty simple. So I know something, and I want to share with you that I know it, or that I have it, without actually explaining you exactly that I have it, just proving that I have it. So that is zero knowledge proof, right? This is what we're talking about. And this you can solve with different mathematical theorems around, and some are probably more complicated than others. Some take more computation power than others. Some can work on a mobile phone. Some need a supercomputer, basically, to actually prove things. And this is useful in many, many ways. So, as you asked, who wants to be in this field? If you want to be in this field, I think the best way to go in this field, if you are a mathematician and you want to really change something in the world and you have your name written somewhere really big, go on research in zero-knowledge proofs, because zero-knowledge proof is something where we have not seen the end, right? It is still under construction. It has a lot of difficulties. For me, the biggest difficulty is that if I take such a product, there are products out there, there are algorithms that you can take and put into your product. So we're building a blockchain. So if we put this in and I don't fully understand how it works, it does not make me feel good. So I think what I would love to see at one point is zero knowledge algorithm which is explainable so that people like me, computer scientists, can actually say, yeah, I understand why that works. That would be really cool.
Yeah, I think I can agree with you, like building some level of abstraction that is totally enough to trust what you're using, and also having many different type of implementations and many people included in such process in building this abstraction, so we can all trust and use it. Maybe this will make it times easier and better for us. Okay, then I want to put on the heading today, so I want to make the difference in privacy and identity versus the scalability, and where the zero knowledge can be applied better, or it can be used in both worlds pretty fine. Marco?
Yeah. So
you are our product guy, so you can start with this.
maybe I can take this one. So zero knowledge initially were conceived as a privacy-preserving technology. We know that. And in the last year, especially in blockchain, we saw that along with the privacy-preserving feature of ZK, there is also the succinctness feature of a ZK proof. And what I mean by succinctness is that the proof is very small and easy to verify. And in this way, we can take a load of data, compress it, and then just verify the proof associated with the data. And so this brings a lot of improvements in scalability because like at this point, we are speaking about verifiable computations, so you can prove the execution of a lot of data, not re-executing all the transactions, all the computations, but just verifying their execution. And this is quite powerful, and like in the blockchain space, we are seeing that, especially with ZK rollups, you have a layer 2 that batches a lot of transaction, puts it into generates a proof on the execution of such a transaction, and then sends the proofs back to Ethereum or any layer 1 blockchain for the verification on chain. So yes, I will say that in terms of scalability, like we are seeing a rising use of this tech.
Okay, maybe for some of the technical guys here, it will be interesting how actually you make it such way that your layer with the zero knowledge proof, where the zero knowledge proof is submitted, is secure enough and people can trust it. How do you make it in ZK Verify?
So thank you for the question, because it's like what we do with our product at ZK Verify. So actually the generation part of the proof is quite expensive, computationally speaking. And this can be done off-chain, for sure. And also the verification can be done off-chain. But at this point, you have to trust a server that cannot tamper with the verification result, but can send back a wrong result, a misleading result. And so what we're doing with ZK Verify is basically having a simple modular blockchain designed to provide consensus and verify proofs in a decentralized way. So we receive proofs from applications that use ZK technology, we verify them, and then we send the verification result back to Ethereum or any other blockchain where the application lives. So in this way, they can ask about the verification result in a smart contract and get back the result. And you don't have any trust assumption, basically, apart from the one of having your proof verified by a decentralized set of validators, which is like a battle-tested approach in blockchain.
So the intermediate layer, it uses its own consensus mechanism. As a blockchain developer, I can understand some concerns about that people here may have, that it is not easy to trust specific blockchain and its own consensus mechanism without using the security of Ethereum, for example. Do you have some such component there, like using the security and the consensus of Ethereum 1, or your intermediate layer being something like layer 2, or it is totally separate blockchain?
Well, it's a totally separate blockchain and actually is based on Substrate, the same framework that Polkadot uses. And this is done for mainly avoid all the technical complexities and the gas cost of verifying proofs on the EVM. So the EVM doesn't have like any precompile, and verifying a proof costs a lot of gas on the EVM. Like for the more simple one, it's considering 30 gas and Ethereum at $3,000, around $16, $20 for each proof. So like, how can we hope for a wide adoption of proofs if their verification on chain costs that much?
Okay, we actually have to continue with, I want to ask about the identity part, but one last question about this topic. Do you think that Ethereum is doing the right actions to make it submitting such data, like times less costly? So we are going to be able to use it as the layer where we submit such data without being afraid of the high gas costs?
Well, I would say that we can make a comparison to what Layer 2 did for Ethereum. So initially, there was the whole sharding idea and so on, but then we realized that it was way easier to delegate the execution to other chains in a modular fashion. So you have execution on the Layer 2 and then the settlement on Ethereum. And I think that the comparison can pretty well fit with also the ZK proofs verification. So using Ethereum as only the settlement layer, but delegating execution to another service.
Can you please turn
chime in there as well? Because we do quite a very similar thing, actually, because we're also using Substrate, right? So we also built on Substrate as a parachain to Polkadot. And I think this is what you see a little bit as a trend. If you are doing specialized things in blockchain, you don't really only go on Ethereum or something. You have those side chains, whatever you want to call them, parachains, which do specific work and have specific consensus algorithms and are extremely cheap to operate, for example, and you build them on Substrate because in Substrate you have far more flexibility because you're building your own blockchain. So you build the runtime of the blockchain yourself instead of just accessing a blockchain through a smart contract interface. So if you're building complicated things, that you see that also in the Cardano world, they're building their partner network also on Substrate. So this is what people do these days, actually, to not build everything on a smart contract, but to actually broaden their possibilities of building stuff with using technology which allows them to build their own blockchain.
Yeah, I totally agree with you that we need DApp-specific chains and they will be part of our future. But my biggest important thing in this situation is that we need decentralization and security. And it is just not so easy for the other chains, accepting Bitcoin and Ethereum, if we can accept. Yeah, I believe we can. But if we exclude them, the other blockchains are struggling sometimes to ensure decentralization and security as it must be. So yeah, that is my concern.
Yeah, but this is also, so in Substrate you can do that too.
Yeah, okay.
So
let's continue with the identity, in my opinion. Ingo is our specialist in identity, so he can share us what do you think about that, how zero knowledge is related to identity and how it can help.
Yeah, so I think that we've seen quite a lot of identity projects using ZK in the last 2 or 3 years, but that may also be connected to the thing that ZK was like 2 or 3 years was very much a hype in the venture capital world, and it was really good if you said ZK for getting some money. The question is, do you need ZK in identity? And if you try to explain it very simple, then of course you understand. Of course you need it because digital identity is based on a decentralized identifier on one side and on so-called verifiable credentials on the other side. Verifiable credentials are things that you store and then you share with someone. So, for example, a passport or an identity card is a typical verifiable credential in the physical world. Just we now do it in the digital world, but in the physical world, we already had those things. So ID card, your university degree, those things are verifiable credentials. And when you look at your identity card, you see that there's a picture of you. That is nice because that connects to the identifier. But then there's lots of information about you. There's where you live, there's how old you are, what your name is, and all that stuff. And if you want to use this identity card for a special purpose, for example, getting into a bar where you need to be 21, you show your identity card. Now, the guy who looks at it knows your name, knows your address. That's not necessary. The only thing that he has to see, actually, is the picture, because he has to compare it to your face, and the date of birth, so that you can make a quick calculation if you're 21 or not, right? That's the two things. In the physical world, you just put your thumb on this part where your name is. That is what we call selective disclosure. So you only disclose what you really need to disclose, like the date of birth. In the digital world, one could go and say, this is where we need zero-knowledge proofs, because we want to prove that I'm born on this day, but I don't want to share the whole credential, right? So let's make ZK stuff on top of it. Possible, but to be honest, much too complicated, because you can also do that with Merkleization. In Merkleization, you can just have a Merkle tree around the whole credential, and you share an end result, and then you can see, and then you can just share parts of the credential, and you can still see if the end result is correct. So that is much faster. It can be calculated in microseconds, and zero-knowledge proof makes it more complicated. And as I said before, also zero-knowledge proofs tend to put a certain opaqueness on how things work, while a Merkle tree everyone can understand. And that makes it much easier for adoption, because when we talk about identity, then we talk about big companies which use that, we talk about governments which use that, and so on. And they tend to want from us not only that it's open source, but they also want to look in the open source, and they want to understand the open source, because it's really critical infrastructure for them. And if they don't understand what's happening in the back, then they will just not use it. And this is why at KILT protocol, we use the simple, efficient method of Merkleization, because that is easy to understand, and it's much faster. So we opted against using zero-knowledge proofs to solve this problem. Of course, there's tons of other problems which you want to use with zero-knowledge proof, but in digital identity, there's easier solutions.
It was a pretty nice description of the situation, but Martin, as a young developer, can you tell me what is your opinion? Is it really easier to understand Merkle trees than zero-knowledge concepts?
Merkle trees are a concept that anyone can understand. It's really very simple, as opposed to zero-knowledge proofs that even if you have a math degree, it will be tedious to understand. So no disagreement on that side.
Okay, we have one agreement here, okay. And Ingo, then do we have something, at least one, that we can't achieve without using zero knowledge in the identity space? Can you give me such an example?
Directly in the identity space, probably not, because the identity space is well defined in the meantime. So we have international standardizations, we have DIDs and verifiable credentials signed off by the W3C. So they are now on the same standardization level like HTTP. And for everything that we have in there, we don't need zero-knowledge proofs. That doesn't mean that it's not allowed to implement zero-knowledge proofs. So you can, what we do with Merkleization, you can also do with zero-knowledge proofs if you want. That doesn't, it doesn't say in the standard zero-knowledge proof is not allowed. That's not the case. It's just that the customers don't want it. But identity is always connected to many other things. So identity is probably something that's going to work cross-chain, and on cross-chain things, especially when it comes to layer 2s and so on, we have seen really nice implementations of zero-knowledge proofs to actually put together data and have it in a very efficient and low storage way on other chains and stuff like that. So this is where zero-knowledge proof really comes in useful, I think. It is a layer below the rather user-centric application type layer which we are working on. I think when you really want to do things like trustless bridging and stuff like that, then it really can become really interesting to use these things. But I don't see it really on the layer where I work.
Thank you very much, Marco. Yeah, I want to hear your opinion on that because as a product guy, you have experience with zero knowledge.
Yeah, so
it's business point of view, so please share with us.
No, I wanted to add something that, first of all, I didn't know you use marketization, and actually it's a very smart idea, so I agree on that. But also at the same time, like for the wider use cases, like if you use internet, you don't have to understand TCP/IP or HTTP, so you can abstract away that, and the user just goes on the internet and do what they want to do. And I think that the final destination, the final goal will be to not having the user not understanding it, but abstract away the system so that the user can understand the benefits, but it's not important if it doesn't understand the underlying technology.
Yeah, absolutely correct. So the user... Hello? So the user is not interested if it's zero-knowledge proofs under the hood or not. The customer who wants to implement that in their country, they are interested. So I can give you an example. We were working with the DHS, the Department of Homeland Security from the US last year, to define how you probably all know the ESTA thing, right? So if you want to travel to the US, you have to fill out a form in a centralized database 2 days before you go, and then you get an okay back, and then you can travel to the US. That's called ESTA for whatever reason. They wanted to put this on DIDs and verifiable credentials, and they asked us for help. And not only us, they asked a lot of people for help. And then we had this presentation where the DHS presented what they actually wanted to do. And they said, we need a system, it has to be simple. If your solution includes zero-knowledge proofs, please do not apply. Because we are not going to understand what you do there, and this is Department of Homeland Security. So we are talking about the national security of the country. And if there's a piece of software which we don't understand and where nobody really takes the responsibility for how it works, if it really works in every edge case, or if there's maybe a backdoor that we just didn't see, then we cannot use that. So zero-knowledge proof, out. And so this is not the end user. Of course, the end user, when I apply for an ESTA, I don't know if there's a centralized database, a blockchain, or a zero-knowledge proof behind that. I don't care. I just want to travel to the US. But the US is interested in the question.
Well, thank you for your opinion. You were talking a lot about the countries and how they're gonna apply the digital identity standards that you were talking about. Can you tell me more about it? Like, what are the governments doing to standardize such thing? Because I have seen many projects that are, for example, doing some type of modern KYC, which is some type of decentralized, and it is super cool and nice and better, but they are like, their clients are not actually allowed to use this KYC provider because it is not standardized, and this is a problem.
The issue that governments have is that they, in the analog world, in the old world, there were big players in identity because they were issuing credentials, they were issuing passports, they were issuing identity cards, they were issuing driver's licenses, big in the business. And they were really a big trusted entity. And then digitization comes, and when you think a little bit where your digital identity actually lives, the outcome is probably, on the Google server and on a Facebook server. That's unfortunate, right? So your digital identity lives there, and if you want to log into a new service, you click connect with Facebook, and then you're connected. Fantastic. So this is something that governments really don't like because they're losing the touch in the digital world with their own citizens. And this is what they don't want. So all the governments in the world are currently very much interested in getting ahead of that. And getting ahead of such a monopoly or duopoly or whatever you call it, Schelling point we heard before. Actually, for identity, Google and Facebook are Schelling points, I think. To get over a Schelling point is not easy. So you cannot just go and say, I make it better, I make it in a decentralized way. This is not going to work. What you need to do is that you have to agree on how it looks in a decentralized way. And this is what happened in 2016 when we were founding the Decentralized Identity Foundation, which has more than 350 member companies and governments in there. The American government is there, IBM is there, Microsoft is there. Google and Facebook are not part of this thing. And they said, we have to standardize in very simple terms, like a protocol, like TCP/IP, how decentralized identity actually looks. And when we have this standardization, and when this standardization is signed off by the W3C, then all the countries can basically invest in building those systems, and they have decentralized identity as they had before with the plastic cards and that stuff, which is decentralized identity already. So we're just replicating the digital, the physical world into the digital world, and we're making Google and Facebook useless by that. But the precondition for being successful there is that you have the standard. And now, since 2023, we actually have the standard. It is signed off by the W3C. It is on the same level as HTTP. And now people start implementing it. Countries start implementing it. I already said USA, their plan is to issue identity cards on DIDs next year. That's probably not going to happen, but wait 2 years. We currently are in talks with the Republic of Indonesia. Then we were talking with some Arab countries. We see that basically all Asian countries are moving in that direction. So it is actually pretty cool that everyone agrees on that standard, because that makes compatibility, right? I can take then my American passport and actually travel to Indonesia and get new credentials there and add them to my credential list and have them in my digital wallet. That is really, really powerful, but it needed the standardization, which unfortunately took forever.
Totally agree. Okay, one last question, very shortly, please, about the identity. How close we are from that, from using this type of digital identity in our day-to-day lives?
What was the question?
How close we are to using this type of technology in our day-to-day lives, like when we will receive it in 1, 2, 3 years, when we will start using it?
Yeah, it depends a little bit on where you live. And so I think if you live in Asia, probably you're going to use this technology, or sometimes maybe you even use it already without knowing it. It's another technology which is not really transparent that you use it, right? So it's not saying, hey, DID now. It's just a digital passport that you have in a digital wallet. So I think in some Asian countries you already use it. Some other big countries are going to follow in the next 1 or 2 years. US is going to follow, they say in 2025, but I suspect 2026. Europe is a little bit slower. So Europe may be 2030.
Okay, thank you very much. I want to ask something, Martin, because he's our new zero knowledge developer here. Would you like to tell me what is the process of being part of Blocksense, starting with these technologies? What is the way for new developers that can follow your example and start working in this area? Could you give them some advices? The microphone, please.
It's a different process. You're still writing code if you're developing a zero-knowledge circuit, for example, which is still the most prominent way of generating zero-knowledge proofs. You still write code. It's not linear how you're used to. You're building a arithmetic circuit, connecting all the wires, and you just need to understand that everything is being evaluated and all at once, which can be hard at the beginning. There are not very many resources to learn about how to write those. The whiteboard ZK sessions have been very useful. You can try to Google those. Also, the Zero Knowledge podcast is what I would recommend for starting out.
Thank you very much. Marco, yes, I'm listening to you.
Yeah, so I wanted to add something on top of that. And basically what we're seeing right now, so the old school approach was to write circuits for a specific proof scheme, and that is very much optimized, but very much time consuming. Like writing a circuits in the past years could require up to months of work and necessitates a very deep knowledge of how the entire system works, so the expertise out there is not very much. But what we're seeing in the last year is the rise of ZKVMs that basically are a virtual machine that allows you to write code in C++, Rust, and so on, and then they take care of compiling that high-level code to circuit code, which is not super optimized, not as much as circuits, but at the same time provides entry point to every Web2 developer, basically, with the knowledge of these programming languages.
This is super nice, and I believe this is the way to adapt this technology and actually use it if we need it and want it. I also wanted a few tools, like the best tools in your opinion that are right now used in the zero knowledge field, just to help again people start using and looking for it.
I want to shout out a project. There is a programming language called Noir. It's a domain-specific language for writing zero-knowledge circuits, which is very much like Rust in some sense in syntax, but it has some constraints. This is some hybrid approach to writing circuits, because on the other side you have something like Circom, which is very hard to use. And on the easy-to-use side, you have ZKVMs, which, as Marco said, are not very optimized. In the middle, you have Noir, which still generates a circuit in the intermediate representation of the proving system that you're using. But it's very much like the regular code you would write.
Okay, thank you very much. Because we have to finish our discussion, it is very interesting for me. I hope it is interesting for you as well. But one last question, and please one or two sentences for it. What are your predictions for the future of zero knowledge? Like your biggest dreams, maybe? Marco?
Can I go?
Yeah.
Okay. So, what I would like to see and what I hope I will see is zero knowledge finding real world use cases outside of blockchain. Because in blockchain, yes, we're exploring ZK proofs for scalability, for privacy, and so on. But what about bringing these features to Web2 projects, Web2 applications that use ZK for these properties, but then settle the verification result on a blockchain? So like you have privacy, you have scalability, but also you have censorship resistant by publishing the verification result on a blockchain. And I think this is a very overlooked space right now.
Ingo?
And just adding that, because it wasn't said, I think it will have a big future in preventing Sybil attacks here and there.
Okay. And Martin?
It's very early for me to say where the future is, so I'll leave you with their opinion on that. Yeah.
Okay. So if we can conclude with something, the zero knowledge is not our decision for every problem we have, but it literally can help us achieve better and better world. So yeah, this is it. Thank you.